dear children. Today we are going into the next part of our lesson. So you aren't you becoming very interested to do things in this lesson? Yes, isn't it? Because I saw that many of you are doing the experiments and taking your video and sending it to me. When you do things on your own, what happens? You learn more, isn't it? More than what teachers tell you. When you do and learn, it becomes more effective for you. So whatever teacher is doing here, you have to try it out from home also. Because you all have got different types of magnets. Now, in the previous lesson, what did we learn? We learned that the magnets have got poles, isn't it? Which are the two poles that the magnets have? North pole and the south pole. And why are it called poles? Because the maximum or the more amount of power, that is the attraction power, is on the poles of the magnet. So we saw that through the experiment what we did that day, isn't it? So when you put iron powder, the more attraction is on the poles of the magnet. So it is the north pole and the south pole. So that is one property of a magnet. What is that property? The magnets can attract magnetic substances. That is the property of the magnet, and the attraction is more on the magnetic power is more on the poles of the magnet. So that is very clear for you. Now today we are going to learn two more properties of magnets. So what is the first property? So I told you that our magnet is connected with our earth, isn't it? So if I have a magnet and I want to know the north side of my house, okay? I want to find out which is the north, which is the east, and which is the west, and which is the south. So you also will be having north and south and east and west for your home. Do you exactly know the north of your house or east side of your house? East we can make out, isn't it? When the sun is, which side the sun is rising, if you look, you can find out a little bit, you can understand which is the east. But how do you find out the north of a place? For that, we can use a magnet. So we are going to know the properties and the uses of the magnet. So we can use the magnet to find out the north of our house. How can we find out the north side of our house using a magnet? For that, what must we do? We must tie our magnet with the thread. So teacher has tied the magnet with the thread. Okay, and I have hung it here. So when you hang it like this is called as freely suspended. I am not touching here. I am just holding this scale here. So it is hanging down and I am not touching it, isn't it? Now it is rotating. I am just giving it a push. So it is rotating and then it will come to a standstill. Now it is slowly stopping, isn't it? When it is stopping, which direction it is standing? It is coming in this direction, isn't it? So what can we do? When it stops like this, now somewhat it has come to a standstill. Now we have to see where is N and where is S. So if you look like this, we can see the N is on this side and the S is on this side. That means the north pole is here and the south pole is here. So what is the property of the magnet? When you freely suspend a magnet, hang a magnet like this, after rotating, it will come to a standstill. It will stand in the, or it will rest in the north-south direction. Okay, it will rest in the north-south direction. Now it is resting, isn't it? So which is the north of this room? Here, north is here and south is here. So which is the north of this room, which teacher is standing, or north of this place? That is the north. this, my back is the south. Okay, so which will be my east? When I am standing facing the north, I am facing the north now. So I am facing the north, my front is my north, my back is my south, my right hand is my east, okay, and my left hand is my west. Is it clear? If we are facing the north, so I am facing the north now because this magnet is standing like this. North is here, south is this side. So this is my north, my back is my south, my right hand, this is my right hand. My right hand is my east and my left hand is my west. So isn't it easy to find out the north of my home if I have a magnet? Yes, isn't it? Now I am turning like this. I turned like this. Can you see? Now which side is it showing? Again it is showing north. Even if I am turning. Now I am turning like this again. Can you see? Again when I am turning, it is showing the north. Now again when I am turning this side. Okay, can you see children? When I am turning this side, again it is saying the north. The north is not actually here, it is this side. Okay, so again I am turning. When I am turning also, the magnet is showing the north itself. So what did we learn from this? A freely suspended magnet always comes to rest in the north-south direction. So if you have a magnet with you, can't you find out the north of your home? Yes, isn't it? Now, you might have a doubt. Okay, if it is a ring magnet, will it come and stand in the north-south direction? I have a ring magnet here. For the ring magnet, how do you know the north and the south? If you want to know the north and the south, what are we to do? It's like this. Okay, one side will be the north and the other side will be the south. For a ring magnet, one side with this side, one side will be the north and the other, this side will be the south. So how can you know which is the north and the south? When you hang it this side, whichever side comes and faces, that we know that is the north. So whichever side comes and faces the north, that side is the north of the magnet. Okay. So here you can see somewhat this side is showing that side. So this is the north of the, I have not marked, there is no marking on the ring magnet. So how can you find out the north? We already know the north of this place, isn't it? So when you hang it like this, whichever side is facing, that side will be the north and the opposite side is the south. So this did you understand? I hope you understood. So what is the property we learned from this? A freely suspended magnet always comes to rest in the north-south direction. Wherever you turn. I turned the whole room, I turned right round, isn't it? Whenever I turned, what did we see? It is always showing the north-south direction. Now we are going into the next property of a magnet. So for that we need two magnets. So I have two magnets here. Okay. So I hope you can see here. This is north and this is the south of this magnet. And again this is the north and this is the north and this is the south of this magnet. Now I'm keeping this magnet on the box. You can see I have kept the north and the south like this. Okay. Now I am bringing this magnet close to it in the center. So it is coming and sticking here, isn't it? This is the north, this is the south. So down is the south and the top one is the north. Here this is the north and this is the south. So when I am bringing it close, what is happening? When I am bringing it, it is coming and sticking on this side. Okay. So now what happened? Which one and which one? Which pole and which pole has joined together? Attracted together? Yes, we can see the north and the south has attracted together. Okay. Now, I shall turn the magnet here. And I am bringing this end to end here close by. Is it sticking? what is happening? It is moving away. You can see when I am bringing north and north together, you can see I am just holding it very loose. You can see the magnet is moving away. When I am bringing it to south again, you can see it is attracting. So what did we understand from this experiment? What did we understand? Yes, we understood that the north pole and the south pole of the magnet attracts. That means north and the south, they are called as opposite poles. They are called as opposite poles. So north and the south are opposite poles. So what did we see here? The opposite poles attract. And what did we see here? The like poles, they are moving away. Okay. They are moving. I am holding like this. Can you see? When I am bringing it close, see the magnet is running away, isn't it? It is running away. Huh? So this property is calling as repelling. Running away means repel. Repel means not attracting. Meaning of repel is going away. So north and north, when I am bringing it together, what is happening here? It is repelling. So north and south and south. So north and north are called as like poles. Like poles means same poles. Unlike pole means different poles. So like poles are repelling and unlike poles are attracting. So here we can see that the unlike poles attract and like poles repel. So now this is north and north. Now if I change south and south together, this is south and this is south. If I change south and south together, again it is repelling. Okay. So this property, did you understand? So what is the next property what we learned? So like poles repel and unlike poles attract. Okay. So this is the property which we are learning today. So you have a bar magnet with you. If you have one more magnet, you can use your ring magnet or you can use a horseshoe magnet which you have and do this experiment from home. Okay. So like poles repel and unlike poles attract. And one more property, what did we learn? We learned that a freely suspended magnet will always come to rest in the north-south direction. Okay. So you have to do this experiment also from home. Now you have a table in your textbook which is given there, isn't it? What is the table given here? You can see A, B, C, and down again you can see those things which are given here. In that they have given you certain situations. Find out the situations in which the attraction takes place and then situations in which the repulsion takes place. So we know the property of the magnet, what I taught you just now. Like poles repel and unlike poles attract. So keeping that property in mind, find out the situations in which attraction takes place and the situation in which repulsion takes place. Now you have a compass like this in your home, isn't it? What is the use of this compass? Why is this compass used? This is called as a mariner's compass. We learnt in social studies, isn't it? Who invented this? The Chinese invented this. This is called as a mariner's compass. What is called as who's called as a mariner? A person who goes into sea is called as the mariner, isn't it? So this is called as a mariner's compass. Why is it called so? In olden days, people used to travel by ships to different countries to find out different countries or discovery they used to do, isn't it? So they do not know the direction. So what do they use during that time? They don't have mobile phones or they don't have wireless to find out which is the direction. So they used to use this mariner's compass. And what is inside this mariner's compass? There is a magnetic needle. This needle is called as a magnetic needle. And you can see there are two colors for the magnetic needle. One is red and one is white. The red has got an arrow at the end. Can you see? It's got an arrow at the end. Now this red side with the arrow will always point to the north. It will always point to the north. So in this compass, you can see markings are there. North, west, east, south, isn't it? and the earth, it is in divided like the latitudes, you know, isn't it, the latitudes and the longitudes. So that degree is shown here. You learned already in social, so I am not explaining too many. You have already learned latitudes and longitudes in social. So here the markings are given on the compass, isn't it? So north, south, east and west is also kept. So how will you see the direction of your home using this compass? You have to keep it like this in a place where it can rest. I hope you can see. You have to keep it on a place where it rests. Now, you can see the needle is showing this side. We already knew that the north of this room is that side. This place is that side, isn't it? So, here the needle is also pointing to that side. But down you can see south is coming there. So, what must you do? You must turn your compass in such a way that the north will come and rest on this needle here. When you turn the compass also, the needle will always look into the same direction. The needle will not turn because it is a magnetic needle. So what must you do? You turn and bring your north correctly. So now the needle will come and rest. Keep it correctly so that the needle comes straight in connection with N. Can you see? You have to keep it, turn and bring N onto that needle. So now this is the north. If you look in this compass, you can see this is the north, this is the south, that is the this is the east, and that is the west of this room. So using this Marinus compass, we can find out the direction of our home. Without the compass, teacher showed you how you can, using a bar magnet, you can find out the north, south, east and west of your home. With a Marinus compass, correctly you can find out. So what I said was correct, isn't it? I said north is here, the opposite side will be the south, your right hand will be your east and your left hand will be your west. So this is also coming in the same way. So this Marinus compass was used by navigators in olden time to find out the direction when they used to go for navigating. And also in the military, people use that when they go into the forest, they don't know the direction. So if you have a compass, suppose you get lost inside the forest also, you can find out your way using a compass. So find out more things what you can do using the compass and write it down. So few more, two are already given in your textbook. You have to find out more uses of this Marinus compass and write it down and let me know. So we know the two properties of the magnet we have learned. What is it? A freely suspended magnet will always come to rest in the north-south direction, and the like poles of the magnet will repel and the unlike poles of the magnet will attract. So these are the main two properties of the magnet. Thank you, children.